I'm going to talk about factoring. In particular, we're going to talk about factoring out the greatest common factor. That's the first thing you look for when you're factoring an expression. We're going to start with a couple of basic problems that are polynomials that have monomial common factors, and then we're going to move beyond those basic problems. So let's jump in with this one. The directions will say factor, and we have x to the 17th plus 4x to the 13th minus 7x to the 5th. We look at our coefficients first, and I see a 1, a 4, and a negative 7, and there is no numeric common factor aside from 1. And then I move to the variables, and I see that they each have an x to a power. Remember, we look for the smallest exponent. In this case, the smallest exponent is a 5. So we're going to remove an x to the 5th power and see what polynomial we have left. Remember, if we start with an x to the 17th and we factor out an x to the 5th, we would have an x to the 12th remaining. We subtract those exponents, so it was 17 minus 5 to get the 12. We move on to the next term, and we have 4x to the 13 minus 5 is 8. And here we have an x to the 5th, and we factor out an x to the 5th, so we don't have any x's left, so we just have minus 7. So we have this polynomial factored. Remember, you can always double check and see if you have it right by distributing. So I could distribute the x to the 5th through and confirm that I get back to the original problem. Also, double check when you're looking at your problem and make sure that you don't have any common factor in this set of parentheses, because if we have a common factor, it means we didn't take out enough. Let's factor one more polynomial. It will look like this. The directions say factor, and we have x to the 11th y minus 7x to the 3rd y to the 4th. Again, I'm looking at the coefficients first, a 1 and a negative 7. There's nothing in common besides 1. X to the 11th and x to the 3rd gives me an x to the 3rd in common, so I'm going to take out that x to the 3rd. We also have some y's in common. Notice we have a y to the 1st and a y to the 4th. The smallest exponent is a 1, so I'm going to take out a y to the 1st. And I set up my set of parentheses to figure out what my binomial will be here. I started with an x to the 11th, and I pulled out an x cubed, and so I have 11 minus 3. That means 8, so I have an x to the 8th. I had one factor of y, I took it out, so there are no factors of y left. We move on to the next factor, and we still have that minus 7. X to the 3rd got taken out completely. We had a y to the 4th, we took out a y to the 1st, that means we have y cubed left. And again, we look to see if we can factor this binomial any further, and we cannot. There's no common factor, and in this particular video, I'm not going to have any problems that would then factor further, but in other videos that we'll do beyond the basics, you might be able to go another step. But with this one, x to the 8th minus 7y to the 3rd, there isn't any other strategy we can use, so it's done. Now let's move on. We're moving to this expression right here, x to the 3/7 plus 4x to the 1/7. Notice it is not even a polynomial because I have exponents that are fractions. They are not positive integers. So this is not a polynomial, but we can still factor the common factor out the same way. Notice each term has x to a power, and we look for the smallest exponent. So we have a 3/7 and a 1/7, so 1/7 is smaller. So x to the 1/7 is our common factor. And to figure out the exponents when we're writing our expression inside the parentheses, we subtract those exponents again. 3/7 minus 1/7 is 2/7. So I have x to the 2/7, and then I have a plus. And here that x to the 1/7 was factored out completely, so I'm just left with 4. So my answer is here, x to the 1/7 times the quantity x to the 2/7 plus 4. And it's done. Let's do another one. This one has 3 terms. Doesn't matter, we still handle it the same way. Notice 9, 2, and 19 just have a common factor of 1, so I'm not going to take any numbers out. But we look and we see there is an x in each of these terms. We have an x to the 7/4, an x to the 3/2, but remember 3/2 is equal to 6/4. So in my head, I'm thinking 7/4, 6/4, and this one is 5/4. So my common factor is x to the 5/4. And we figure out what needs to go into the parentheses so that if we were to distribute that x to the 5/4, we'd get back to the original. So our first term is 9x to the 7/4 minus 5/4 is 2/4. That's equal to 1/2. Minus 2x to the 3/2 minus 5/4. That's 6/4 minus 5/4 is 1/4. And for the last term, we factored out the x to the 5/4, so we're just left with 19. And this one's done as well. Now, nothing says that our exponents have to be positive. Let's look at this problem. The directions are to factor completely. Notice we have negative exponents. Makes it a little more entertaining, but our process is no different. So let's start with the coefficients. We have a 5, and a 35. So this time we have a common factor of 5. Additionally, we have some factors of x. Remember, you look for the smallest exponent. We have a -2, a -3, and a -4 as the exponents on the x. -4 is the smallest. So I'm going to factor out x to the -4th. So I look up here at the first term. I factored out the 5 completely. I had an x to the -2. I factored out x to the -4. And remember, to figure out what the exponents are, you subtract. -2 minus -4. If you need to, go to the scratch paper and figure it out. We have -2 minus -4. That's really -2 plus 4, which is 2. So our exponent here is a 2. Let's move to the next term. The 5 got factored out. Our exponent on the x will be -3 minus -4. That's a 1, and I'm just putting that 1 in for emphasis. And for our last term, we had a 35. We factored out a 5. That leaves a 7. The x to the 4th got factored out completely, and it's done. You can take a peek here and look at this trinomial, but it is not factorable with respect to the integers, so this one is done as well. How about this one? I thought I'd put a little mix of positive exponents and negative exponents in the problem. Doesn't change what we do. I don't see any numeric common factor besides 1. We have an 11, a 6, and a 1, so I don't have a number to bring out. The exponents are -2, 3, and 8 on the x's. The smallest exponent is a -2 then, so we'll factor that out. So for our first term, we'd just be left with the 11. With our second term, we'd still have the 6. And we have x to the 3 minus -2 is 5. And for the third term, we have 8 minus -2, that's 10. And we have it factored. I would actually take one more step and rearrange this polynomial here. and write the x to the 10th first. We don't have to do that, but I just prefer it. Put it in standard form, so we have x to the 10th plus 6x to the 5th plus 11. And that does not factor any further over the integers, so it's done as well. Now I want to talk about what happens when the common factor is not a monomial. This next one, it's a monomial, but we're going to start with this one so you can see how similar it is to the following one, where the common factor is not a monomial. So let's just do this one quickly, this first one. 5a to the 30th plus 7a to the 29th. I hope you can see that the common factor is a to the 29th. We'll take that out. And then we're left with a 5a for the first term, and then just a plus 7 for the second term. And it's done. But our next problem that I have right here is very similar. Mathematically speaking, we handle it in just the same way. Though instead we have an a plus 9 to the 29th rather than an a to the 29th in common. So let's factor out that a plus 9 to the 29th. And I'm going to put brackets here because I know the expression here will be a little more complex and it's going to have parentheses in it. But notice I have parentheses around that a plus 9 so I could raise it to the 29th power. Now I'm still looking at these two different expressions. This 5 times a plus 9 to the 30th. So I had 30 factors of a plus 9. I took out 29 of them. That means I only have one factor of a plus 9 left. It was 30 minus 29. So 5 times a plus 9 to the first. And from the second expression right here, I factored out all a plus 9s. All of 29 of the factors came out, so I'm just left with the 7. But now there's some simplifying we could do and need to do. Sometimes people argue and say, well, it doesn't say to simplify. But that goes without saying. We're not going to present our answer that way. So we have our a plus 9 to the 29th. And we have 5a plus 45 plus 7. And now my parentheses are taken care of, so I don't need to leave this expression in brackets. I'll go back to parentheses. So I have a plus 9 to the 29th times 5a plus 52. I look to see if there's any other common factor. There is not, so this is considered factored. So remember, this problem that we just did was very similar to this first problem we did. It's just instead of an a, we had an a plus 9. Let's look at another one similar to that. Here it is. Factor completely. Do you see that we have some factors of 3x minus 8 in common? Here we have a 3x minus 8 to the 47th. Here we have a 3x minus 8 to the 46th. The smallest exponent is 46. So let's take that out. 3x minus 8 to the 46th times, I set up my brackets. This first expression, I'm factoring out 3x minus 8 to the 46th, so I'm going to subtract the exponents. 47 minus 46 is 1, so I have 3x minus 8 to the first. Minus, and on this second expression, I took out all factors of 3x minus 8, so I'm just left with a 2. And as with the previous problem, we're going to distribute and simplify. So I have 3x minus 8 to the 46th times 33x minus 88 minus 2. Let's combine like terms. and I would have 33x minus 90. But notice, there is a common factor of 3 that's now apparent. We need to continue. This set of directions says factor completely. That means you need to factor until each factor is prime. And this is not prime because we have a 3 that we can take out. So let's do that. The 3 comes out, and we can put the 3 right in front of her, or we can put it in the front of the entire expression. I'm going to put it out front. That's where we normally put monomials. So the 3 comes out. We still have that 3x minus 8 to the 46th. And now we have 11x minus 30. And now we have it factored completely. Let's look at this next one. I changed the directions just a little bit because I wanted you to have an additional strategy available to you if you choose to use it. The directions say factor completely using substitution. And I'll show you what I mean by that. We could do this problem that I've written here exactly like we did the previous two. But sometimes people prefer to make a substitution so it looks a little bit simpler. So notice we have an x plus 4 to the negative 4th and an x plus 4 to the negative 3rd. So the substitution is we're going to replace x plus 4 with a single variable. You could make it an a or a u or a y. You just can't let it be x because x is already in the expression. So I'm going to we'll let u equal x plus 4. And now I rewrite the expression with a u in place of x plus 4. So I have 5u to the negative 4th plus 9u to the negative 3rd. And some people prefer to work with this. Just looks a little bit simpler, easier to identify what the common factor is. Now notice our exponents are a negative 4 and a negative 3. The smaller of those two numbers is negative 4. So we're going to factor out a u to the negative 4th. And then let's see, from the first term we would just be left with a 5. With the second term we subtract the exponents. Negative 3 minus negative 4 is 1. But the problem was presented with x's and not u's. So we need to substitute the x plus 4 back in. So everywhere I see a u, I put in that x plus 4. So I have x plus 4 to the negative 4th times 5 plus 9 times x plus 4. And now, as in the previous two problems, we have some tidying up to do. So let's combine like terms. So I have 5 plus 9x plus 36. So our final expression is x to the 4th raised to the negative 4th times 9x plus 41. And we have it factored. Now notice it was a little bit longer, but some people prefer to use substitution because they find it easier to identify the common factor. So you get to choose when you're doing a problem whether you want to use substitution or not. So let's do this next one. And I want to point out that the directions do not say to use substitution, but you can. If you look at this expression and it's hard for you to figure out that common factor, I would encourage you to make a substitution. So I'm going to do that. Let's let 2x plus 7, that binomial, equal, let's make it y this time. So we'll let y equal 2x plus 7. And I'm going to let everything else remain the same. So I have 8x to the 10th y to the negative 28th plus 6x to the 11th y to the negative 29th. And again, notice how nice it is to look for the common factor right here. And again, that's the benefit of making that substitution. We have an 8 and a 6. Common factor is a 2. We have an x to the 10th and an x to the 11th. Common factor is x to the 10th. We have a y to the negative 28th and a y to the negative 29th. Take care, especially with those negative exponents. The smallest exponent is a negative 29, so I factor out y to the negative 29th. And now I figure out what needs to go in parentheses. So I look at them term by term, so focus on that first term. So I had an 8, I factored out 2, that leaves 4. X to the 10th got factored out completely. We had a y to the negative 28th, and we took out y to the negative 29th. We subtract those exponents. Negative 28 minus negative 29 is a 1. And I just wrote that 1 for emphasis. We have a plus, and now we're looking at the second term. We have a 6. We factored out a 2. That leaves a 3. We had an x to the 11th. We took out x to the 10th. That leaves x to the 1st. The y's came out completely, and we have it to here. Remember that we must finish with just x's because that's the way the problem was presented. So we need to substitute back. These values for y are being popped back into the expression. So I have 2x to the 10th times 2x plus 7 to the negative 29th times 4 times 2x plus 7 plus 3x. So the only thing I did from the previous step to the current step was substituted the expression back in for y. So now let's simplify. We have 2x to the 10th times 2x plus 7 to the negative 29th times 8x plus 28 plus 3x. And in our last step, we just combine like terms inside these brackets. And again, now there's no need for the brackets. We can go back to parentheses. So here is our answer. Just bring everything down. And when we combine like terms, our last factor is 11x plus 28. I don't see any common factor there, so this one is done. And again, I chose to make a substitution because I wanted you to see that a second time. So that's a tool you have in your mathematical tool chest. Substituting. If a problem looks complicated, consider whether substitution would make it easier for you or not. Let's do this next problem. Factor completely. So this time I'm going to choose not to make the substitution because I want you to see it both ways. If you prefer on a problem like this to make a substitution, go ahead. In fact, I would make 2 substitutions, like x plus 1 could equal a, and x minus 3 could equal b. And then look at your simpler expression. I'm going to factor it the way it looks. So here we go. 7 and 4 have nothing in common besides 1. We have x plus 1s to a negative 5 power and a negative 6 power. Negative 6 is the smaller of those 2 numbers, so our common factor is x plus 1 to the negative 6th. We have x minus 3 to the 90th power and to the 91st power. The smaller of those 2 exponents is 90. So out comes an x minus 3 to the 90th. So what are we left with? For this first expression, we have a 7. We had an exponent of negative 5 here. We factored out x plus 1 to the negative 6. So negative 5 minus negative 6 is 1. So I have x plus 1 to the first. All the factors of x minus 3 got factored out. Now we move on to the second part of the expression. So we have the plus, we still have the 4. The x plus 1 to the negative 6th got factored out completely. We had 91 factors of x minus 3. We took out 90. When you subtract, that is 91 minus 90, you get a 1. And now we can simplify. X plus 1 to the negative 6th times x minus 3 to the 90th. Depending on your comfort level, you may be able to do this simplifying in your head. The 7 times x and the 4 times x, you know those will be combined. Let's do it. 7x plus 4x is 11x. Similarly, we have a 7 times 1, that's 7. 4 times negative 3 is negative 12, and that would give us a negative 5. If you think you would goof doing that algebraic simplification in one step, then don't do that. Take an intermediate step, show that distribution, and then combine like terms. I just wanted to show you that at this level, it is okay to do that. We're going to do one last problem. So here it is, factor completely. Again, I would encourage you to make a substitution if you find it easier to do that. I would make the substitution of 6x plus 1 right here, make that equal to y. But I'm going to factor this one without making a substitution. So here we go. We have x's in common. We have an exponent of negative 2/7 and 5/7. Negative 2/7 is smaller, so I'm factoring out an x to the negative 2/7. We have 6 plus 1 to some powers. The exponents are 10 and 9. The smallest of those two is 9. So the common factor is 6x plus 1 to the 9th. So let's figure out what we have left. X to the negative 2/7 came out completely. We had 6x plus 1 to the 10th. We took out we took out one factor. We took out 9 factors and we're left with 1. So we have 6x plus 1 to the first power. For our second expression, we had x to the 5/7. We took out x to the negative 2/7. So we have 5/7 minus negative 2/7. That's 7/7. And that is, of course, 1. We had 6x plus 1 to the 9th. We factored out all of those, so we don't have any 6x plus 1s left there. So let's simplify. We have x to the negative 2/7 times 6x plus 1 to the 9th times, we have a 6x minus 1x, that's 5x, and we just have that plus 1. And we have this factored as well. So I hope you can enjoy factoring some more complex expressions by taking out the common factor.